Hey, Star Labs, Spatial Temporal Abstraction Representation. I've said this a bunch of times now, but I'm going to keep on saying it because the core acronym for me, how I came up with it. But Star Labs is a venture I'm doing that's basically a startup and a research lab. And the goal is to have the speed of a startup with the rigor of a research lab. And as you can imagine, that's pretty hard if you're not a frontier AI research group like OpenAI, DeepMind, and so on. So me being neither a PI or a research assistant, but one person in this lab right now, I have to find my ways to do certain stuff. And it's learning, right? It's like an independent research project, but a lab, right? So it's like multiple things. So right now I've just found some a couple ways. So I just want to share that for this episode. One thing I found, and it sounds really simple, is to do a lecture review. Because like in this, like, oh yeah, that makes sense. You're doing research, but very especially for independent project, I think it's easy to have an idea in your head and like what may be the solution and just jump into that and test some stuff. But I feel I don't even feel with literature reviews, you don't make a mistake there because with literature reviews you get to the baseline much faster instead of finding out halfway through your idea that someone's already done this 10 times better. Right? I think with literature reviews it also helps to develop an internal understanding of what's being done and why something is being done. Because once you start going to the next step, which is using agents to do a lot of the experiments, then you're able to make much more crucial decisions faster and understand why you did something. Like you can actually defend your choice. And saying that, let's go to the next step. With the next step, what I actually do to help me move much faster, especially being like one person, is I use Cloud Code to do a bunch of the experiments. So instead of me like designing every experiment meticulously, I just have Cloud Code plan it and build it and execute it. Or I execute because the native world model game engine and work on the representation. A lot of times it's me executing it. But the point is, Cloud Code does a bulk of the work there. And instead of me, just like, okay, I'm going to go on the whiteboard and plan this and plan this, Cloud Code does it. I think what helps is that previous understanding from the literature review and understanding papers is that it's not just me saying, oh, Cloud Code, what happens here, what happens here, what happens here. Because oftentimes it doesn't have the exact context I'm working on, it doesn't have the exact knowledge I'm working on. I don't fault it for doing that. But then if I don't have an internal understanding of what I'm doing, we both get lost, right? Because with Cloud Code, I see it less as a self-driving car, but more so the driver. So not the driver, the car itself. Right. So me being the driver, I have to make the choice on what direction we go into. So whether it's left, right, or straight, I have to make that choice. And the only way I can make that choice is if I have an understanding of what I'm doing. So Cloud Code really just helps a lot in terms of getting there much faster. Although, to make sure I don't accumulate too much technical debt, I create reports. So the reports serve to, first and foremost, show me what problems arise during the work session, or remind me of what problems arise during the work session and what solutions were used to address it. So if I was to see that problem in the future with a similar experiment, I could be like, hey, I've seen you before. Here's the solution. Get it done really quickly. But also allows me to develop a high level understanding of what's being done behind the scenes at like the cogs. Because like, okay, I need to understand like why certain things like if like something is really not working, I have to have some understanding of the architecture, not like like the smallest details, like oh this happens here and this function does this, but having an understanding of the architecture itself allows me to say, hey, just from my understanding of this problem and understanding of how this works or this works, this probably is a crucial piece in this architecture that I have to fix because Cloudcode can find a lot of the bugs, right? Maybe some take some time, but like it can do that. Um, and with the report, it also helps because I can also plug into Notebook LM, create a podcast. So when I'm doing a passive task like walking or washing dishes, I can develop I can listen to a podcast of what was done in the prior Cloud Code session because then I can like, okay, this was done. And when I hear it, it now stays in my brain longer versus reading. Plus, I'm also a paper guy. I don't want to print a bunch of stuff right now because I'm back at home, but I'm a paper guy, so like I don't really like reading stuff on my laptop, especially for these reports. So it's nice just be able to hear it in my head. I'm like, okay, yeah, this happened, this happened. It's also really cool because like it makes you sound way smarter than you are. Because like with Notebook LM, I think they have this understanding or they expect to be like this novel research papers. Like they make you sound like Einstein. I'm like, no, that was just really just like just for convenience sake that I did X, Y, D. I can't speak X, Y, or Z decision. Um, but those are like the two, or like those are a couple of the things I've learned to do. I also just have everything organized. So before I even start an experiment, I have a clear goal, which is something I wasn't doing before, and it caused me a bunch of trouble. But I have a clear goal for each experiment. So right now, I'm looking to native world model game engine and the representation part of that. So should you use meshes? Should you use Gaussian? Should you use voxels or whatever? And the issue is that I'm testing the combination of meshes and Gaussian. So like for each experiment, I have to make sure okay, I'm not just testing that broadly because it's a very broad problem, but I'm testing, okay, does this work for does the meshes actually connect to Gaussians if I'm doing this? Does this work for elastic bodies? Does this work for fluid bodies, rigid bodies? Does Does the mass and spring approach work? Doesn't it? Doesn't okay. Move on to this next thing. Test this. Test this. Does versus instead of using like a spring function, can I use like an energy function, right? Does that work? So like with each experiment, I test like an atomic thing. That's very important. Not like to the smallest detail, but like a simple detail that's like, okay, this is the one thing I did. I don't get too confused. Like it allows me to move much faster because once I get that thing done, I already know what the next atomic step is. And then after like 5 or 7, I can like, okay, I have a full understanding of this. I can move on to the next big stage. Um, but even with all that, I do still think it's kind of daunting or troublesome because like I don't know that much. Right? I'm not an expert. I'm a sophomore at the University of Maryland, College Park, trying to do my best with this world model thing, and I just don't know that much. Like if someone was to get into like world models like last week and like dedicate a bunch of time and be very disciplined, I fear they could be as knowledgeable as me or even more so. And I think the problem with that is that when I'm trying to, um, I can't use this fully as a learning opportunity because I have to still execute. It's like sometimes there'll be a time where that's a weird way to phrase that, but there'll be a time where there's a crucial decision that has to be made for a local problem in what I'm doing, right? So it's not fully important to the large architecture. It could just be like, oh, how should this be computed for this stage? That's probably going to be changed in the next like 3 stages. And it's, oh, dang, this is probably something I should know. But then it's like, okay, I could spend like a day, I could spend maybe 5 hours learning how to do this and then find the answer. I have understanding. But then it then slows me down. Because if I'm doing that for each local problem, how long is this going to take me? Because it's already a big problem in itself. So to go multiply the problem doesn't really make the most sense. So a lot of times I do have to sacrifice that and for the sake of executing. So I'll be like, okay, here's a mixture of expert approach to like go solve this problem, or if I'm just lazy, Claude, figure out the best plan. Um, I think that's sad. I do think that there's a overestimation on my part about how long or how much effort should be taken into something like this. I think the way I was brought up, the education system that I'm going through was built prior to AI, right? That makes sense, obviously. But then what that means is that my expectation of how I should accomplish something, how long it should take, is based prior to like AI. So like if even with a simple coding task, like okay, I expect myself to like do this and this and this. And I'm like, oh, maybe it's gonna take like 5 hours or whatever. But I have AI tools that can do that in like a minute, right? So it's like I have to I struggle to properly frame my expectation of how something should be done and now how I should learn. Like even with learning, it shouldn't take like I don't have to go through every YouTube video. I don't have to go through every textbook. I can like okay, condense this as a chapter. Let me go read this paper. Let me write my notes, and that could be moved much faster. So I think that's something I'm still learning to do to rebuild that foundation, take the best elements of the traditional approach of learning and also like the new elements of the new way of learning and executing tasks and combine it to have a proper framing of mind. Because once I do have a proper framing of mind, it does allow me clarity in my decisions on what to pursue as a execution task, as a learning task. Um, but yeah, I think it's nice. I think it's going pretty well right now, even with the representation thing. Like I was talking about that earlier. I think it's going really well, right? We're making a lot of progress. But I do think it's daunting because with the stuff I've done before, they've largely been done, right? Like let's go very early on, even before coding. I was doing animation. With a lot of animation, a lot of stuff I was doing at my like early level was something that like anyone could do. So like I could still see like the higher level stuff, like a nice movie or a show. I'm like, okay, that's like the level of stuff I can do. So when I was doing my own task, I was like, oh, this is impossible. Like I can know how a ball can bounce, right? And then when I went to coding or building apps, was similar to that. So I wasn't very often like the stuff I was building, like the apps I was building, it was never in it really wasn't the case that I was building like some novel algorithm the world has never seen. It was more so I was combining components from the apps that work best, whether it be like a swipe feature or this goal, and then making a new app, right? So it's more so a novel experience, which is still hard to do, but like it was something that still existed before in some way. But with research from this problem to or the one I was doing prior, it often feels like I'm operating like the frontier, and it's like it's very scary because it's very often like there's no necessary like footpaths to follow. It's like you could just be wrong. Like this mess Gaussian post could be wrong, and then it's like it's not a waste of time because I still learn stuff. Like it could be wrong, and I have to go to another thing, right? I could just even be looking at the whole problem wrong. I think that's much more scary than I realized at the beginning. Because like the more and more effort you put into this, the more and more you realize you don't know, and you have to like learn. Um, But man, it's cool though. It's cool because like it also does feel nice. Because before I mentioned like in a prior video, I mentioned how there's a bunch of startups in the world model space, especially recently. Even though a lot of them are more so focused on robotics, which is its own tangent. But then with this being like the frontier and me more learning more and more stuff and seeing gaps, it's nice to see a lot of the startups in the space don't necessarily have the answer. It's like I don't know what the answer is, but I know what the answer is not. Right. So it's really cool to like at least have that at least have that breathing room. Even I can't take too much conflict. Like even now, this is like my second or that's a lie. This is like my seventh time doing this video. So after the sixth one, I already made this point. And I looked at my Twitter and I saw something that had like something really cool. And I got scared that was something close to what I was building. But it was more video based. So I do have some breathing room there. But the point is, I can't take too much comfort, but I can at least have it's at least nice to know that the answer isn't easy to find, right? And everyone is still struggling. Besides Google, the behemoth, I think Google probably has something crazy they're cooking up in terms of 3D based world models, but who knows? Um, I do think it's exciting. I do think it's exciting because like even though I'm just one guy for now, approaching this problem, this massive problem, right? It's exciting to know that like I'm still doing it, and I still fully believe, I still fully see the future in which I'm the one who largely finds the answer, or I largely contribute to find the answer. I think the best analogy I can give to this is the show One Piece. It follows Luffy, right? And he's just one guy at the start, and he's like from the East Blue, not like the most popular sector of the world in this show, and he wants to become the Pirate King, which is a very far goal. It's a very far-reaching goal because you have these massive powers, the Yonkos, who are much more like infinitesimally closer to the One Piece than he is, which based on certain stuff it's not as true. But the point is that's like you're this one guy, and then you finding people and do working on yourself and like growing as a team, you're able to get much more close. And even in the show now he is, and that's after like 20 years, right? And I hope to do it faster. To be fair, in the show it's like 2 years, but like in real life it was 20 years. But the point is I hope to also um I see myself in that same situation in that I know I'm not one of the large powers or one of the large groups pursuing this problem, but I do vehemently believe that I'm going to be the one to either find the answer or contribute. I'm going to be one to build it, right? I really want, even though it's like a research program, and it's like about contributions to the field, which I really want to do because I think it's really exciting. It's like really cool to like be a scientist and contribute to research. I largely know I want to build this thing. I think that's more of like the engineering side of me. It was like as much as I want to contribute, I'm still going to do that and share my findings. I'm going to be able to build a native world model game engine. And it's largely just exciting. I think the passion that I get every day, even though it's not something that drives me each and every hour, but like waking up and thinking about it, sleeping and thinking about it, like just eating and thinking about it, it does make I don't say life more exciting, but it's just fun. Right? It's just fun. And I'm excited. I'm excited for it. So that's pretty much where Star Labs, Spatial Temporal Abstraction Representation Labs is at. Those are my notes in case you're doing something similar. Maybe it's like another lab taken from a TV comic show. Um, but besides that, I have nothing else to say. So have a great day.